All right, ladies and gents, welcome back. We are on lesson 4 of this unit, so unit 3, lesson 4, and it is graphing in standard form. I have my ruler, I have my graphs, and I have my notebook. As long as you have those things, you are ready to go. So the first thing I'm going to do is I'm going to go ahead and define what is standard form. Standard form is when an equation looks like ax plus by equals c, where a, b, and c are just numbers. So an example of this would just be like 2x plus 3y equals 6. And we want to be able to graph when it's in this form, when it's not already set up for us in slope-intercept form. So there are 2 ways that we can do that. In method 1 is when you solve for y, which puts the equation into slope-intercept form, and then you graph. So you can solve for y, get it to look like your y equals mx plus b, where remember m is your slope and b is your y-intercept. Your y-intercept is also your starting point. I'm going to put that in parentheses so I don't forget. And then I just graph like I did in my last video. So we're going to try one of those first. So the first way we can do that in example 1 is 2/3 x plus y is equal to 3. Right now we can tell that our y is not completely alone. So in order to get our y completely by itself, we have to subtract 2/3 x from both sides of our equation. When we subtract 2/3 x, it cancels out over here. I'm left with my y is equal to 3 minus 2/3 x. 3 minus 2/3 x, which is the same thing as y equals negative 2/3 x plus 3. So you can write it either way you want, whichever one you are more comfortable with. And then, a little blurry, there we go. Then we're going to identify our slope, our m, which remember that's our number right next to our x, no matter where it's at, still the one right next to our x. So in this case, negative 2/3, which remember is your rise over your run. And then your b is at a positive 3, so as an ordered pair, is 0, 3, which is our starting point. So then we pull one of our graphs over. I went a little crooked. Sorry about that. So we pull one of our graphs, and we write y equals negative 2/3 x plus 3. My starting point, my y-intercept, is at 0, 3. So I put a point right there. And then my rise over my run is a negative 2/3. So from my first point, I go down 2, and I run 3. Down 2, run 3. I ran out of space, so I go back to that starting point and go in the opposite direction. Up 2, to the left 3. Then I ran out of space, so I pull over my ruler, if I could pick it up. Go ahead and connect those, and put my arrows in either direction. And I just graphed in standard form. So that's your first method of solving for y, and then just using our, what we already know, using what we did Monday night. Okay, there's a second method though, which I'm going to write on the back. Method 2, make sure it's straight. Okay. Method 2 is solving for the intercepts. Solving for the x and y intercept. I'm going to write down two definitions just to make sure that we remember them. Your y-intercept we already talked about. Your y-intercept is the point at which the line crosses the y-axis. So therefore, the x-intercept is going to be, drum roll, the point at which the line crosses the x-axis. So just like every line has a y-axis, every line has a y-intercept, they have an x-intercept. Now, I shouldn't have said every, but most of them have an x and a y-intercept. Okay? So we're going to try that with our example 2. Example 2 says negative x plus y is equal to 4. Negative x plus y is equal to 4. Well, in order to find my y-intercept, what I need to do is plug in a 0 for my x and then solve. So in this first one, negative x plus y is equal to 4. I'm going to plug in a 0 here, plus y is equal to 4. And my 0 cancels out, so y is equal to 4. Awesome. So my y-intercept is at 0, 4. When y is 0, when x is 0, y is 4. So let's do the opposite. Negative x plus y is equal to 4. Now I'm looking for my x-intercept. So I need to plug in a 0 for my y and solve for x. So negative x plus 0 is equal to 4. My 0 cancels out. So now I have there's still negative x there, is equal to 4. Well, how do I get my x completely alone? I divide by a negative 1, and my x-intercept is equal to a negative 4. Now that I have that, I can put my ordered pair. When y is 0, my x is negative 4. I got that ordered pair. I take my graph now, and all I need to do is plot those 2 points. One is at 0, 4. One is at negative 4, 0. Now that I've got those 2 points, I take my ruler and I connect them. That's all I have to do when I'm solving using the intercepts. So I just plug in a 0 for either my x or my y, depending on what I'm solving for, and then I solve from there. We're doing awesome. I'm going to put one more example on here, example 3, and that one I'm going to leave in our notes, and I want you to try it on your own before you come to class tomorrow. So it's 4x plus 3y is equal to negative 12. So that one's a little bit more challenging. 4x plus 3y is equal to negative 12. And we're going to look at that graph tomorrow during class. All right. Have a wonderful evening.